So today we'll start with Truffle Suite. So it's a set of tools and softwares that actually help you streamline the process of developing and deploying smart contracts over Ethereum, an Ethereum-based blockchain platform. So what it says on the website is a world-class development environment, testing framework, and asset pipeline for blockchain using Ethereum virtual machine, aiming to make life as a developer easier. That's what they say on the website. And it provides some of the things that are a lot of things, but some of the things that I have mentioned here, the critical ones: built-in smart contract compilation, linking, deployment, and binary management. So usually, like, we have to select the version of compiler and everything while compiling our smart contracts for Solidity, right? However, like, Truffle automates the whole process and downloads the binaries and everything. It manages everything and compiles the smart code with the compatible APIs. It has advanced debugging with breakpoints, variable analysis, and step functionality. So this part of it is based on the Truffle dashboard, which is a GUI tool, when in-browser GUI tool to do those things. It also has automated smart contract testing for rapid deployment. So, like, we have JavaScript testing using Mocha. That's same like it is. It has its own testing functionalities. Actually, it's also based on Mocha, the JavaScript one. So recently they have also added testing using Solidity scripts. So that is also a new thing, but usually it was done using Mocha. Deployments and transactions through MetaMask and with Truffle dashboard. The one I mentioned, Truffle dashboard and MetaMask. So you can actually integrate it with your browser and MetaMask, and you don't have to use the mnemonics and private keys every time while deploying. And network management for deploying to any number of public and private networks. So once you compile the smart contract, you can deploy it to any number of networks by managing their accounts automatically using the tool. So what's the difference between a web app and a decentralized app? So on the left, we have image showing the web app. So for a web app, we have a server with a database, a backend like Python, Ruby, PHP, and a front end using HTML, CSS, JavaScript. So the server serves the front end to the browser renders it, and using the UI, we can communicate to the backend with the Python, Ruby, or PHP, and which communicates with the database, and the whole application works in this process. But for a decentralized application, we have a bunch of these nodes. These are Ethereum nodes, and these Ethereum nodes are connected with the front end directly. So the front end is served from any source. It's just HTML. You can download the HTML, render it in your browser. It can be a React app. It can be served by a server. It can be served through IPFS as well. Okay. And once the front end is loaded, the front end will ask if the MetaMask is available or not, or any Web3 provider in the browser is available or not. And the Web3 provider will connect to the front end, and the Web3 provider in the front end will connect to one of those nodes. The nodes can be any nodes that is exposed to the internet, or it can be your own hosted node or a light node, any node. And then it renders on the browser, and the rest of the process is similar. So for the end user, it is very similar, just they have to maintain their own wallet and a Web3 provider in browser, and everything else for the web applications and decentralized applications are same. So outline of this tutorial, today we'll install the prerequisites for starting with Truffle Suite. Then we'll understand the Truffle workflow. So of course there is a workflow on developing and designing smart contracts and finally deploying them. We'll understand that, and next we'll move on to creating and testing a Truffle project. So we'll create a project, we'll test the source codes in those project, and then finally we'll be compiling and migrating the project. Migrating means deploying. Migrating means you are migrating it from the source code to the deployment phase on a real blockchain. And we'll also use the CLI, the Truffle CLI, to interact with the contracts. So that's a CLI tool. And finally, we'll have a front end, a React-based front end to interact with the contracts using Truffle, using MetaMask. So the installation of prerequisites, first we have to install Node.js. It is recommended to use between version 14 to 18. So in this tutorial, I'll be using version 16, the version 16 LTS. And we can use Node version manager, of course, for that. Next, we'll have to install some prerequisites things like build essentials and Node GUIP for compilation of the smart contracts. And then we have to install Truffle globally so that it's available as a command line tool. And finally, we have to check the installation of Truffle, which is which Truffle, so that it shows where Truffle is located on our machine and the Truffle version. So let's quickly try these things here. So I have already installed Truffle here using npm install -g Truffle. So let's try Truffle. So you see it's located here, and that's the version. So Truffle is successfully installed. If any of these commands don't work, especially the which Truffle, and it shows blank, that means Truffle is properly not installed, and you might need to install it properly first before you proceed with it. Next, after installing the prerequisites, we have to understand the workflow. So the workflow works in this way. We initialize a Truffle project using Truffle init, and then after initialing the project, we create and edit the smart contracts. So by default, the project might not have any smart contracts. So we have to write our own smart contracts. We have to design them. We have to build the logic and everything. And then after creating the smart contracts, we create test cases. Of course, before we deploy it to the blockchain, we have to test it thoroughly for any bugs. So we create the test cases, and the testing of the smart contracts is done. Once testing is complete, we move on to compiling the smart contracts and then migrate or deploy the blockchain to the smart contracts to the blockchain. So initializing the Truffle project. So once we run Truffle init in our directory, project directory, once we do that, Truffle init, this is the folder structure that would be created, a blank project. The blank project would contain the root directory of our project and a directory for smart contracts. This is where we will create our smart contracts. Migrations, this will contain scripts for deploying the smart contracts on the blockchain. The test, this will contain the test cases and testing scripts. And finally, truffleconfig.js is a configuration file for the Truffle project. Let's quickly try this here. So let's go back. So we created a folder named testproj, and let's cd into it. And let's try Truffle init. So it shows Ganache successful suite. So once we do that, let's key into this, and you can see this is the folder structure. This is how it is, similar to this one. Now that's an empty project. Of course, we cannot move on with an empty project for our tutorial. So we'll be using a preloaded project using the Truffle unbox command. The unbox command, we specify a project name that is predefined, and using the project name, it will load that whole project onto our project directory. It's similar to git clone. Okay, so I have already done that, and we are already in this folder called React. It has the client. The client contains the source code for the React app, and Truffle, it contains smart contracts, the migrations and scripts, node modules. Of course, we have some node dependencies. So for that, we have it here, the scripts and the test. So you can see this is the structure of the React box application. Now, checking out the smart contract. So it's a very simple smart contract here. And I think anyone who has visited the Remix editor might remember the smart contract. This is the first smart contract that is available for it. It's pragma solidity and a storage, simple storage. So you just have a variable and you have a setter and a getter for that variable. A very simple smart contract. So checking out the testing script now. So let's see what's in the testing script. So there are two files here. If we check and test, there is this simple storage, a JavaScript file, and a Solidity file. Both of them do the same thing. They both test our smart contract. So looking at the JavaScript file, we can see we initialize the contract here, and then we have some assert statements. Assert equal value 0. This is the first test case, the second, and the third. And before that, we see that here it is written write to write 1. So this is the calling the write statement to set the value. This is the setter function. And before that, we get the value here, read. And dot to number is a function to convert the big number. Big number is a type in JavaScript that is used to convert to the number or the integer format. Of course, we have to do it for every single cases. Otherwise, it will show as a bn object. And similar is the solidity file. We have these as statements and of course the functions. So for some reason, the syntax highlighting for solidity is not working currently in my editor. But yeah. Now testing the smart contract. So testing is very easy. It's just truffle and test. Truffle test. So let's quickly test our smart contracts here. So we have to cd into the directory. Let's exit from this one. Let's go into cd.ru. So we have to move into the truffle subdirectory here, this in directory. And then we run truffle test. Okay, what it says? Oh, so yeah, we have to have a blockchain network before we do that. So let's quickly run up a Ganache instance. So we type Ganache and it's started. Now what we do is we have to copy this mnemonic here. Copy this mnemonic. We go to the configuration file. Remember the configuration file? And we paste our mnemonic here. This long string. Once that's done, it can import our accounts and use it to test. So it started here. Let's run it again. So using network deployment, it's compiling the smart contracts and it's starting the tests. You see, simple storage test, write test value, the first test case, and second test case should read newly written values, both of them pass. So two are passing. So if one of them are failing, the whole test would fail. So once we have tested the smart contracts, we can move on to the deployment and compilation part. Let's move on with the slides. So compile the smart contracts located in the truffle/contracts directory. We use the command truffle compile. Again, very simple command. So you just write it, compile, and everything is up to date. Why? Because we already compiled it here. It's compiled already here, so it has cached those results. So it didn't do it anymore. Now, once we have compiled the smart contracts, we have to deploy them. And migrating the smart contracts to a blockchain from Truffle has three different ways to do it. The first one is, of course, using the development environment. So Truffle has built-in Ganache that it can spin up by running the Truffle develop command. It will spin up a Ganache instance as well as it will give you a CLI to execute the smart contracts and compile them and deploy them. Next option is having a Ganache or an Ethereum client. So in this case, we are using Ganache, but you can use the Ethereum client we had in our previous tutorials. And using the Truffle CLI, we can deploy it. And the third one is using Truffle dashboard to connect to MetaMask on the browser and deploying it. So of course, we'll try the first one and the second one, but the third one would be a take home assignment for you guys. Okay. So of course, the class is getting over. So if you try, you try. We'll never know, right? So migrating on Truffle development environment. So what we do is we spin up our Truffle develop environment. So develop. You see, the output is very similar to what we had here. I don't think I'm gonna find that anymore. Yeah, now I found it. See the accounts and everything. The output is very similar. So it has spun up its own development server at 9545 because our Ganache instance is running at 8545. So that's done. Also, the mnemonic is here everything's present here. So what we can do is we can run the compile command or test command. So for testing, we don't have to use anymore the truffle command because we are already in the truffle CLI development environment. So we run test test and it would compile. And of course, it's not compiled for that environment, truffle development environment. So it will compile again. And of course, same thing, same as compile, do the same thing without the truffle command. And finally, we can deploy the contracts using migrate. We don't use the truffle command because of course we're in the environment already. So migrate, and you see it's starting the migration. Network name develop or network ID 5777. Block gas limit. This is the limit. One, deploy smart simple storage .js. So we have this migrations folder. You can see this script is here, JavaScript file. This script is actually executed, so it's replacing simple storage. It's already deployed, so it's already replacing that one. So this is the transaction hash of deploying the block smart contract. Blocks 0, smart contract address. This is the smart contract address on our blockchain. Block number, where it is located. Block timestamp, the account from where we deployed. So you can see this account here with the first account 022 0x224a. So 0x224a, the first account. Balance, how much balance we have left after we deployed this one. The gas price, gas used, the gas price, the value sent. If we have to send any ether, we didn't send any, of course, so it's 0. And the total cost in ethers. And the total cost, of course, if it was multiple smart contracts, there would be multiple of these tables here. In that case, the total cost would be more than what it was mentioned here. And finally, the summary, total deployments 1, and the final cost again mentioned here. Now, once we have deployed the smart contract, we can get an instance of the smart contract and execute some commands to it. So let's obtain the instance. So it is done by using let instance equals to await simple storage dot deployed. So you see here that replacing simple storage, this name, whatever the name of the smart contract was, it deployed it as this name here. And if we copy this, let's just simple storage dot deployed. So INS is this huge thing, smart contract instance with a lot of function variables and everything, that's object. And let's execute this command here. So await instance dot read. The smart contracts instance dot read. Read is that getter function in the smart contract. We read the value and then two numbered. So let's do that. Let's first see what it shows without the two number function. So it's a bn object, -0, word 0, length 1, read null. That's a big number object. So in order to read this big number object, we have to actually convert it to a number. So okay, it's 0 by default. So once we have done that, let's change the value by using the setter function. So it's the write function here. So you can see await write dot instance dot write 1. So let's set it to 1 and it will show this transaction receipt with transaction ID, the receipt hash and everything, the details. We also saw these details when we were trying with Ethereum, right? When we transfer Ether from one account to another, we saw the same thing, transaction hash, everything. It's similar to that. So ins.write, and let's try 2 this time and await. Of course, it's an async function, so we have to use await for that, synchronize it, and see. There's a transaction ID, transaction hash, transaction index, block number, which block it's committed to, the block hash, from which account to which account. This is the smart contract account, cumulative gas used, contract address, and log blue. Okay. So once we have done that, let's again verify that it really used that. updated that. So source 2, right? Okay, let me quickly make it bigger. I think you can see it, right? Or was it too small? The text? It was visible, right? It should be better visible now. Next, we have setting up Truffle config. So we already used the development console of Truffle to do it. Now we'll use Ganache and Truffle CLI to deploy a smart contract. So before that, we have to do npm install -g. Globally, we have to install Ganache. However, I've already done that, so I can skip that. And starting the Ganache instance using Ganache command. So you saw previously that I did the same. And we have to set the Ganache instance details in truffleconfig.js. So you remember I went to truffleconfig just a few moments ago. So this is the thing I actually did. This thing is this one. So I have to set the network. So there is this networks object in the config. And the networks object, we have to create this network instance called development. Or you can name any other also. There is an advanced one, you see. There is a Guarelli instance. So all of the network instance that we are going to use are going to be shown up here. So for development, we have the provider. We use the HD wallet provider and of course the mnemonic, the host where the node is located, the IP address, the port, and the network ID. It's set to start here, but you can set it to the network ID of Ganache or whatever instance you are connecting to. So once that's done, you can use truffle migrate dash dash network development. So let's now deploy it to Ganache. So we can let it, now let's close it. So now we are not in the development environment of Truffle, so we'll be deploying to Ganache. So to do that, we use truffle, Truffle, migrate, that's just development. The same thing will happen to Ganache. You see, it's done. And this time you see the address would be different. Guys, use contract address. Of course, that or not just the contract address, but where we are sending it from. Account, yeah, this one, 35. 35 would be an account of, yeah, this account of Ganache, the zeros account. So it's deployed here already. So once we have deployed the smart contract, we can use it using the client. So we have to quickly run npm install for that in the client directory. So let's go to the client directory and run npm install. Already I've done that, so it's gonna take a few moments. Otherwise, it would take some time, considerable amount of time to do it. So it's done. Once we have done that, let's start the front end. And it's showing that, yep, this is the address. So let's copy it and let's open a browser. Oh, no, no, no. We have to use Chrome here. Chrome. Where is Chrome? So Chrome, and we paste the address. So once you have pasted, you see my MetaMask popped up because it is this application is requesting for the HD wallet provider. So I have to authenticate and give it permission to access my account on MetaMask. So once I've logged in, you see it shows local test at the network. So I have to connect to, already have, it has connected to it, but nothing is showing up here as accounts. So I have to import the account. For that, we have to go to the Ganache instance. Oh no. Okay, yeah, let's quickly copy this private key of the 9th, 10th account because otherwise we won't be able to use it. And let's import that account here. Import account, private key string, paste it here, import. And we have 1000 ether. Of course, this means it's imported from the Ganache instance. And once you have done that, let's quickly reload it. So you can see we have the smart contract here, and here is the read function, a button, and a write function with the value we have to set. So if you click read, you see 0 is showing here. And for writing, we can set, let's set it to 3 this time. And if we set write, see MetaMask is popped up to verify. Okay, yeah, I have to actually switch the account here. Yeah, the transaction would fail. Not connected, so I have to connect this account. It is important and it's connected. So latest account, that one. And once I've done that, lets me read once again and write. Yep. This time it should work. Account 15, yes, very likely in less than 15 seconds. The time, transaction time. And Ether and balance, everything is showing. So confirm. And it write that. So let's read it again. Let's see if it changed. It changed. So that's the front end, how it works. So let's quickly browse through the source code of the front end to understand how it's actually working. So we have a slide here for that. So overview of React and MetaMask. So the Web3 instance, we obtain the Web3 instance from the Web3 provider, or by default, the WebSocket localhost 8545. And then for accounts, we await for the Web3 instance and we get the accounts. If any account is allowed by MetaMask, of course, that account will show here, as the accounts is the array of the addresses. And the network ID to get the network ID to which we are connected. And ABI, of course, the ABI would be destructured from this artifact object. So ABI is the application binary interface of the smart contract we're trying to connect with. And let address and contract. So we obtain the address from the network and we obtain the instance of the contract. And once we have obtained the instance of the contract, it is very similar to how we issued commands on the command line to interact with the contract. Okay, so let's quickly browse through the front-end code here also. So in source, we have this app.js, and you see it is calling the ETH provider to initialize the provider. And the ETH provider, we have this intro, setup, demo. So demo is imported from components. And if you go to components and demo, you see, not this one, sorry. Oh yeah, in this folder, contracts, we have this ABI here. This is the ABI of the symbol storage smart contract, already mentioned here. And in the components directory, we have this demo. I'm going to the index. You see that it is state and value, set value, the hooks user. And here in this case, we have the state artifact, no, it is no artifact, and contract buttons. Okay, the buttons that we used and the contract instance here. And the contract instance, we go into the contract instance, we'll see that we have that value setting here. Yeah, this one. You see value set line, and then in this span we have that value that changes the color, different color, and here we set the value. The rest of the smart contract is written here. So we obtain the value. How you obtain the value? Look here, use effect, and we have this value. Okay, wait a minute. Yep. Class list remove hash. Okay, this is the animation, not the value. So value is passed here. So if its value is passed here, value is use state. No, I think it is loaded from the another application here. And for the contract buttons, here we can set the set value function and test set input value parse interact. Yeah, we call the contract and there is the write function with the new value and send, and yes, we have the read value to read the value, and these values pass to the other components where it shows value. This is what I was trying to find the line. So that's how React works for web apps. So that's pretty much it for the presentation here. So of course we learned about Truffle Suite and its features. We installed the Truffle Suite and initialized the project. We tested, compiled, and deployed the smart contracts. And we explored how the Truffle development environment works. And we also connected to the Ganache instance and deployed it over there. So what are the next steps that you can follow from here on? So learn how to build and use front end using Web3.js and React. So just not just writing smart contracts is enough. You have to have a UI to actually make that application usable. To learn about that, and then you can explore the Truffle Suite. So Truffle Suite is not just limited to whatever we discussed here. It is way beyond what we showed here. So learn about it and try to use it because it's a very streamlined process for developing smart contracts and deploying them. Finally, you can explore and learn about the Truffle dashboard. So that's one of the newest addition to the Truffle Suite and understand how it enables seamless debugging and deployments for smart contracts using user-friendly UI. Okay, so that's pretty much it. Here are the references, the Truffle Quick Start documentation, the React Box project, Truffle, the Ganache documentation. Thank you. Any questions? No questions. Yes, I've recorded. It's recording here. Will I stop the recording? Let's stop.